So a real life example that's dealing with exponents is when we're looking at compound interest. With compound interest, this is when we are putting money into a bank account or something of that nature where our interest is going to accumulate. And there are different ways for your interest to accumulate. Your interest could be compounded annually, semi-annually, quarterly, monthly, or it could be compounded continuously. There are all different types of ways to compound interest, and it just kind of depends on what the problem at hand is telling you. So the general formula for compounding interest is A equals P L plus R over N to the power of N times T. So what does this tell us? A is our final amount. P is also known as the principal slash initial deposit. R is our rate. N tells us the number of times that it's compounded in a year. And T is time. And that has to be in years. If it's not, you need to convert it so that it will be. So for instance, if I have let's go $2,000, and we're looking at 5 years, at a 3.25%, and this is going to be compounded annually. So how much money will a $2,000 deposit grow to in 5 years at 3.25% compounded annually? So with this, we have to use that formula. So we have A equals P times 1 plus R over N to the power of NT. Okay, so just as kind of like a refresher or what we're putting where, A is what we're trying to find. P is that $2,000. R, because it's currently a percent, we need to change that into a decimal. So it's going to be 0.0325. N is compounded annually, so that means we only do it once in a year. So N is 1. And T, we're trying to figure out how much it'll grow to in 5 years. This is assuming that I'm not going to add more money into this, and I'm not going to take any money out of this. So I'm going to just go ahead and plug it into my formula. A equals 2,000 times 1 plus 0.0325 over 1 to the power of 1 times 5. So the great thing with this, Because we're just looking for the A value, you can just plug this right into your calculator and it should do it for you. It's when you get into this is how much I have left over with this rate, and I'm trying to look for P, that it gets a little bit different. And it's just like an algebra, any old algebra problem. So when we type this into our calculator, after 5 years, we will gain about $346.82. So that's how much will be in our account after 5 years. So let's look at a situation where we need to find how much our principal started at. All right, so after 10 years, Megan has $5,000. Her account was compounded quarterly at 2.75%. How much did she initially deposit? Again, we're still using that same formula. So looking at this changes up a little bit. That A is 10,000, is 5,000. P is what we're trying to find. R, again, it's a percent, so we got to change it to 0.0275. N is compounded quarterly, so it's compounded 4 times in a year. And T is 10. All right, so we've got 5,000 equals P 1 plus 0.0275 divided by 4 to the power of 4 times 10. So I'm just going to go ahead and simplify that 1 plus 0.0275 divided by 4 and take it to the power of 40. This is going to give me a better idea of that number in order to get P alone. So we've got 5,000 equals P times. I'm going to round this to 1.3153. So looking at this, all I did was simplify my parenthesis and I took it to the power of 40. I'm then now going to divide by that 1.3153 to that 5,000. And P equals $3,801.44 approximately. So there are different ways that you can manipulate your equation in order to solve for a different variable.